Welcome back to my channel. If you're aiming for a 9 in GCSE Maths, you're in the right place. I'm Tanvik Hang, and today I'm going to share my top tips on how I got 99% in GCSE Maths. I'll break down the most common mistakes people make, how to avoid them, the best techniques to answer some tough questions, and my top tips on how I got 10 9s at GCSE. Let's get started. Many students lose easy marks because of simple mistakes. Let's go through them now. Mistake number 1 has to be the most common mistake people make, and that's not understanding the question. I'll go into more depth later in the video when we tackle some hard questions, but if you find yourself in this situation, just take a breath, underline the key words in each sentence, and take it one sentence at a time. Mistake is not showing your working clearly. If your answer is correct, you could still lose marks if you don't show your method. If your answer is incorrect, you could still get some marks if you show your method. So always show your method. The next mistake is ignoring keywords in the question. This links back to the earlier mistake. Underline every keyword in the question. If it says 3 significant figures, make sure your answer is in 3 significant figures. Don't drop easy marks. The final mistake is rushing your working without checking for errors. Now you realise this is the only mistake which is actually to do with the maths. It just shows how many marks you can pick up with just correct exam technique. How to avoid these mistakes? Always show every step. Even if the answer seems obvious, show every step of working. That way you'll guarantee some marks. Next tip is to practice your time management. The best way is to do past papers. Have a look at my other video which explains how to best use past papers. But this will give you a feel of what the actual exam is like. Practice these, get your timings right, and one other tip, don't just skip to the end of the paper and start with the harder questions. I know they're more marks, but start with the easier ones at the front. Final tip on your exam technique is to check every one of your answers. If you finish the paper early, go through each of your answers and check from the start to the end of it. Make sure everything makes sense. Now let's go through the tips that can get you a 9 in GCSE Maths. First up, you can't expect to get a 9 if you don't know the content. So reread your notes and make a cheat sheet which summarises all your notes on the hardest topics. That way, just before you go into the exam, you can look at this just to jog your memory. Second tip, which is especially useful if you don't understand some of the content. Go on to Corbett Maths and search for the topic which you don't get. They've got videos and questions on there, and they've got something called a 5 a day, which gives you questions for each day on various topics. Do the 5 a day once every day until your exams. They got difficulty ranging from beginner all the way to advanced. And you'll see, maths is all about practice. So make sure you do some practice papers. I'd suggest doing at least 5 before your actual exam. Once again, look at my other video which explains how to best use past papers. Now we all know that the questions at the end of the maths paper are the hardest. Let's go through some of them now. Right, so now let's do one of the questions at the end of an Edexcel GCSE Maths past paper. So, first things first, let's underline the keywords in the question. 7 red counters in a bag. The rest are blue. More blue than red. And 2 are taken at random from the bag. The probability that there will be 1 counter of each colour is 7 over 15. So 1 counter of each colour, 7 over 15. Work out the total number of counters in the bag before any counters are taken from the bag. Okay, so we don't actually know the total number in the bag. That's what we're trying to work out, total number. So let's call that X. So X is the total number. Now, this is a probability question. Probability question, we usually need something called a tree diagram. That's what we're going to use now. So you write red and blue, then you write the probability of each. So red is going to be 7 over x, because x is the total, and there's 7 red counters. We don't know how many blue there are, but because the bag just contains blue and red, it's going to be x minus 7 over x. Number of blue over the total number. And now I repeat this. Red and blue. And red and blue. Now we don't actually need to know all of these. We just need to know one counter of each colour. So the only ones we care about are red and then blue, or blue and then red. So if we take a red counter, what's the probability that we take a blue counter? Well, there's one less counter in the bag because they're not being replaced. They're just taken out and they're put somewhere else. So the denominator is going to be x minus 1. Total numbers decrease by 1. And the top number, blue, well, blue hasn't changed. It's still x minus 7. Now let's do the same for red. So we've just taken a blue counter. How many red are left? Well, there's still 7 red counters. And so now the total numbers decrease by 1. So we just put that over x minus 1. So now what do we do? Well, we only care about this one and this one. So we times them together and then we add that to these ones. So 7 over x times by x minus 7 over x minus 1 plus x minus 7 over x times by 7 over x minus 1. That's what we've got. Now you'll see they're actually both the same thing, because when you times something, the denominators don't really matter. So they're both over the same thing. So this is the same as just 2 times by one of the brackets. So 7 over x times by x minus 7 over x minus 1. Now let's just simplify this. So that is the same as 2 times by 7x minus 49 over x squared minus x. And this is the same as 7 over 15. Okay, so let's keep on simplifying. We've got 14x minus 98 over x squared minus x is equal to 7 over 15. Now we could either times by 15 and times by x squared minus x, but there's a slightly quicker way. Let's divide everything by 7. So that is going to be 2x minus 14. And that is going to be over x squared minus x, which equals 1 over 15. Then we times by 15, and this is a calculator paper. So we have 30x minus 14 times by 15, so 210. That equals x squared minus x. 30x minus 210 equals x squared minus x. Well, let's get everything on the same side. Let's keep x squared as positive. So that's going to be x squared minus 31x plus 210 equals 0. And this is just quadratic, so we can type it in on our calculators. We just go to equation, let's just clear those. And then we just type in the coefficients, so it's 1 minus 31 and 210. And we've got 21 and 10. So x equals 21 or 10. Now how do you know which one it is? Well, this is the total number. So let's say x is 10. Let's go with the lower one first. Well, we know there are 7 red counters, and the blue, so b, is equal to x minus 7. But we know there are more blue than red counters. So if it was 10, then the blue counters would be 3. And that's less than 7, the red counters. So it has to be x equals 21. So that would be your final answer. So this is the final question on that same paper. They're both worth 5 marks. And this is a bearings question. So if you remember bearings, you draw a line straight. That's your north arrow. And then you go clockwise from there. So you go that way. Now, let's do the same approach as the last question. Underline the keywords. Bearing of B from A is 105. The bearing of C from B is 230. So we've got 2 of the bearings. And we've also got 2 of the distances. Distance from A to C is 180. And the distance of C from B is 95. So we want the distance of B from A, and we need 3 significant figures. We're going to have to remember that at the end when we get our answer. So, how should we start this? Let's just put a point somewhere here. That's going to be A. Now, the bearing of B from A is 105. So, let's draw a line straight up. 105, that's just past 90. So it'll be roughly like that. Something like that. So this is A. B will be about there. And now the bearing of C from B is 230. So let's draw a line. 230 is, well, 180 would be there. 230 is going to be somewhere like that. So let's just draw that. That's going to be C. Let's just join them all together. So it's like a triangle. So let's label our angles. So this is 105. This is 230. And now we've got some distances. The distance of C from A is 180. So that's 180. The distance of C from B is 95. So that's 95. Now the scale is clearly a bit off, but it's just a sketch, so it doesn't really matter. So we want the distance of B from A. Now that's this distance. So we can call that X. How are we going to work this out? Well, there's something we can do here. When these 2 lines, they're both parallel, both going straight up, they add to 180 degrees. They're called co-interior angles. So this is 105. This angle here is going to have to be 75. So we have that. Angles around any point are 360 degrees. So 230 plus 75, that's 305. So that would make this angle here 55 degrees. So we've got 55. How can we use that? Well, we've got a distance and an angle. We've got another distance. And we want this distance. So it's not Pythagoras, because it's not a right-handed triangle, right-angled triangle. Instead, we have to use the sine rule. So that means sine of 55 over 180 is equal to the sine of this angle here. So let's call this angle, let's call it y. The sine of y over 95. Now remember, this is a calculator paper, so we can just get our calculators out and just type this equation in. So sine of 55 over 180, and it's going to be times by 95. So that's what we've got, 0.43. So we've got 0.43 equals the sine of y. Now we do the inverse sign. So we choose our calculator, type that in, of that last answer, which is 25.6. Let's keep that in our calculators because we don't want to round too much. But we've got 25. So how does that actually help us? Well, the angles in a triangle add up to 180 degrees. So 180 minus this answer here, which we've kept in our calculators, minus this angle here, 55, is going to give us this angle here. So let's type that in on our calculator. 180 minus that answer minus 55. So we get 99.4. So 99.4. Well, what's that? That's this angle here. This angle is 99.4. Now let's use the sine rule. So sine of 55 over 180 is equal to the sine of the angle we just worked out, 99.4, over x. X is what we want. So once again, we can type this in on our calculator. We've kept the angle because we don't want to round too much before our final answer. So let's do it. So we know sine of 55 over sine of 55 over 180. Then we're going to divide by the sine of our last answer. So it's that answer. And that is equal to 1 over x. So 1 over x equals 4.61 times 10 to the minus 3. So we're going to times both sides. So we're just going to do 1 over this answer, which is x. So that's 216.8. So x is 216.8. But let's go back to the question. As for 3 significant figures. So 3 significant figures, that's going to be 217. So that's our final answer. That's it for today. If you follow these tips, you're sure to get a 9 in GCSE Maths. If you found this video helpful, don't forget to like, comment and subscribe. Good luck with your studies and remember, you've got this. Thanks for watching.